matter with me today. This is different from yesterday's picture. Who remembers what yesterday's picture was? This is a hard question. Sam?
It's the ice cream, it's melt.
Excellent, the ice cream was melting. What is that called when something goes from a solid to a liquid or a liquid to a gas? Zook, what's it called when it goes from a solid to a liquid?
Physical change.
A physical change, yes. I saw some of you melt ice for your homework. Very good. That is a physical change. So what is happening here? He's cooking some vegetables. Ray, what do you think this could be? Could you make some observations or make a guess?
I think it is the...
Well, tell me this, Ray. Are the vegetables different after they're cooked?
Yes.
Yeah? Can you get them back to the way they were before?
No.
No, so it's irreversible. So do you think this is a physical or a chemical change?
I think this is a chemical change.
Excellent, very good. This is a chemical change. He's cooking here. Let me turn off your drawing, silly gooses. He's cooking here, and whenever he's finished, they cannot go back the way they were before. The matter is different. It's changed forever. It's irreversible. Okay, today we all know what to do now. Blue Moon, number 1, please, starting with today.
Your physical change homework.
Very good. Today we will go over your physical change homework. Number 2, let's have Jack. Number 2, starting with today.
Finishing reading about physical changes.
Very good. Finish reading about physical changes, right? Because we didn't quite finish last class. And someone else can read number 3 and 4 together. How about Sue?
Today we will explore chemical change to matter. Today we will read about chemical change to matter.
Very good. So first we will explore on our own and then we will read about it. So first thing is going over your homework and then finish reading about it. So let's take a look at your physical changes homework. I got some really, really good ones. I was really happy with them. All right. Zook did one about a change in the state of matter. The water freezes into ice, and I knew this is a physical change because it changes the state of matter, and it can turn back into water. Zook, that is great. That's a great way to say it. Oh, and I see, Ray, you also wrote about some chemical changes. Very interesting. This one, oh, I see, chemical, physical. Very good, Moon. Okay. I see yours now, Sam. Very nice. Butter and cheese. Whose is this one? Whipping cream. Oh, is this yours, Moon? Moon, can you read your one about whipping cream? I think that's, we haven't seen that one before.
By putting the whipping cream in a bowl and stir it. Taking instead of matter from liquid to solid, it is called a I forget it already.
Try your best to say the word, and then I'll fix it after if you're wrong. It starts with a F.
Physical changes.
Very good. It's called a physical change. Very nice. Okay. Very cool. All right, I see a lot of physical changes. That's great. Susu, wow, Susu had a very good list of materials. And this was soluble and insoluble as well. Very nice, Susu. And then here's your physical changes. Susu, could you read your physical changes for us? Let's pick one or the other, Susu. You can read about this one. or you can read about this one. Which one do you want?
Physical changes when the size and shape changes. I got a paper. It changed its shape and size, but it is still paper. So the matter didn't change.
Excellent. So it's still paper. The matter didn't change. Very good. This is very good, Susie. All right. And, oh, this looks cool. Is this pasta?
My one. That is my one.
Pasta, could you maybe tell us one of them? Can you explain them to us? One of the physical changes.
Like some of them.
You can't read it.
You can read it for us. You can practice your reading.
I scrunched up a piece of paper into a ball.
Okay, and then what's the explanation?
The piece of paper is scrunched up into a paper ball, but it's still paper.
Excellent. It's still paper. It just changed shape. Okay, well, that's mostly the ones I wanted to go over. Again, you will get stickers for that with Miss Kim.
Miranda, my one is good, right?
Yes, it was very good. Yeah,
It was very bad.
very bad. Let's be nice to each other, Pasta. And you can see here, I have a physical change. I cut the tomato. I did not cook it. I only cut the tomato. So again, physical change. Everyone, please read this. 1, 2, 3.
A size
Change.
Excellent. So here we change size and shape. Here we change state of matter, solid, liquid, gas, or gas, liquid, solid. So this is, let's finish our reading now. This is where we stopped last time. The first paragraph. Banana, could you please read this first paragraph for me?
Sometimes the temperature of matter changes. On a cold day, water can change to ice. This is a physical change.
Excellent. So changing temperature is a physical change. Banana, can you say changes?
Changes.
Good. Let's remember our S on changes. Okay. So it got cold. What do you see in this picture? Who can make an observation about this picture? Puppy.
The water is on this bench has changed to ice.
Mm-hmm. Yep, very good. What does the water look like? Does it look like an ice cube?
I don't know.
Maybe like a cone, right? Probably because the water is dripping off the bottom when it freezes, so it makes this long shape. Okay, thank you, Bunny. And who can read the second paragraph for us? Who can read the second paragraph? Taylor, go ahead.
Wetting and drying can be physical change. To wet mud looks and feels different from dry mud.
Very good. Just one thing. We missed the period here. You put the period here. So, one more time, can you say the first sentence?
Wetting and drying can be physical change.
Physical.
To wet mud.
Wait, Taylor. Look, the period's here. So, wetting and drying can be physical changes too. Wet mud, okay, see, we pause right here. So read the first sentence one more time.
The first sentence.
Yes, wetting and drying.
Wetting and drying can be physical change.
Good, okay, perfect, much better. Thank you, Taylor. Okay, so wet mud looks different from dry mud, but it's still mud. What will happen to the ice on this branch? What do you think might happen to the ice on the branch? Maybe in the future? Sino?
It might melt.
It might melt. Very good, Sino. Would that be a physical or a chemical change?
It's a physical change.
Nice work, Sino. Excellent job. So, the color of dry mud is different from the color of wet mud. Everyone, go ahead and circle the mud that you think is dry. Great job. What texture do you think that mud is? How would you describe the texture? Only Taylor has a word for this texture. Rosie, what texture? Full sentences, please.
The textures of the mud is drought.
Is dry, but what do you think dry mud feels like? Do you think it's spiky, smooth, rough, fuzzy?
Rough.
Okay, rough. Very good. And what do you think the hardness is like for the wet mud and the hardness of the dry mud? Who can talk about the property hardness for both? Maybe milk or blue moon? Which one of you? Milk, go ahead. Can you talk about the hardness of the wet mud and the dry mud? That's okay. Milk, maybe you can get us started by reading this box down here. Could you read this for us, please?
The color of dry mud is different from the color of wet mud. Not squishy when it is wet and hard and it is dry.
Very good. So that was a little hint about the hardness. Who could talk about the hardness of wet and dry mud now? Zook?
The wet mud is soft and the dry mud is hard.
Excellent, very good. So these are physical changes. All right, observe the texture. We already did that. What caused the mud to change color and texture? How about Sophia? Sophia, what caused the mud to change color and texture?
The wet mud is light brown and the dry mud is brown.
Yep, so what caused the mud to change color? Why are they different colors and textures? Because one is
in the other is dry and hard, and one is in the rainy days it will be wet and soft.
excellent, great job. One time it's wet and one time it's dry, maybe from the rain, from a river. Okay, now we're all done with
Miss
this.
Mirna, I have one more idea.
Okay, Zook, we're out of time. Remember, we only have 45 minutes, so we can't share everyone's idea, okay? We have to move on to chemical changes. Everyone, please read this definition. 1, 2, 3.
Chemical changes when the matter changes into different matter.
Excellent. When matter changes into different matter, it goes from uncooked to cooked. Using maybe, who knows, something that we use to cook things. For example, we can use an air fryer. What else can we use to cook things? Susu?
Pan.
A pan. So I'll say the stove. Another thing? Sam?
Oil.
Oil. Okay, oil helps us fry things either in a stove or sometimes even in an oven, like when we bake a cake. Okay. And there's also normal to burnt. For example, if we catch paper on fire or leaves on fire. Make some observations about the objects you see in this photo. Who can give me observations? Cherry, can you give me an observation of this photo?
I can see a ball. I can see an egg too.
Okay, very good. Ray, could you give me some more observations?
I see 2 eggs. One is white and one is brown.
Excellent, very good. Ben 10, what do you think these materials could be used for?
These materials can be used for baking.
For baking. Very good job, Ben 10. Thank you. Make sure you're paying attention, okay? We have butter, we have sugar, we have flour. So here we have a lot of different materials. Now, what has she done with the ingredients? Pasta?
She has mixed them.
Exactly, she has mixed them. Very good. I want to come up. Now, this is not a chemical change yet. They're mixed together, but in there, the eggs are still eggs, the flour is still flour, the sugar is still sugar. They're just mixed together. So, who can tell me the physical changes she had to do to make this? For example, she had to crack the nuts. Crack means break. What other physical changes did she do to make this? Jack, can you think of one? Physical changes to make this. Banana? Banana, do you know a physical change she had to do to make this cake batter?
Crack them. Put enough salt.
Excellent. Very good job, Banana. All right, can anyone think of another thing she had to do that's a physical change? Taylor?
I think she needs to put flour in.
To put, say one more time.
I think she needs to put flour in.
Excellent, so she needed to mix in the flour, right? And maybe even the sugar. When you mix sugar with water, it changes from a solid. So, how does this matter change when you heat it up? When you add heat? When you increase the temperature? How does the matter change? What happens? No, not just someone else. Who haven't we heard from? Bunny. Bunny, go ahead. How does the matter change when you add heat?
When I add heat to this bread became bigger.
It became bigger. Excellent. Very good, Bunny. What else changes when you add heat? What about the cake we were making?
The cake changed color.
It changes color. Excellent. What else happens to the cake mix when you cook it? Taylor?
I think it gets more bigger.
It gets bigger. Okay, very good. And is cake milk? Is cake mix a liquid or a solid? This one, the batter, the cake mix. Is this a liquid or a solid?
I think it is a solid.
It's a solid, but what shape is it? Does it have its own shape?
Nope. So it is a liquid.
Very good. So it's a liquid. And what about after you bake it in the oven? Then is it a liquid or a solid?
Solid.
Very good. So this, it changes completely. This is not eggs and flour and sugar anymore. The matter has changed. All right, the eggs cooked, the flour changed, everything about it has changed. All right, it's not batter anymore. It's not a liquid. It's completely different. So these two things, how are they the same? They both, all right, Ray, how are they the same?
They both get added heat.
Excellent. Heat is added to both of them, everyone. Adding heat to both of them.
Adding heat to both of them.
Very good.
Adding heat to
So,
both of them.
how are these different? How are they different? They're both getting the same heat. They're both getting heat, but different things happen. How are they different? All right.
I think the ice is cold and hard, and the muffin is soft and very hot.
Okay, very good. So they feel different. They have different properties. What else is different about them? They're both getting heat added to them, but the cupcake mix doesn't melt. So how else are they different when you add heat? Rosie, what do you think?
When we add heat, the ice melts,
Mm-hmm.
and the flour, the egg, the nut get cooked.
Excellent. The ice melts, the muffins cook, even though they're both getting added heat. Everyone, please circle the physical change. All right, now please circle the chemical change. Which one is a chemical change? Very good. So they're both getting added heat, but one's a physical change and one's a chemical change. Ben 10, can you please read this star for us over here?
Okay. They both increase the temperature of the batter by adding heat. One cooks the batter irreversible, and one makes the batter reversible.
Can you say reversible?
Reversible.
Very good. So this one is cooked from the heat, irreversible. The other one melts, cooks is irreversible. This one melts, which is reversible. Any questions about how this physical change and this chemical change are different? We'll come back to this tic-tac-toe at the end if we have time. If not, tomorrow is a review class. We're going to play games. We're going to do a quizzes. So tomorrow's going to be a fun Friday. First, let's do our reading. For chemical changes. What are chemical changes? Everyone, read the first two sentences together. Everyone read these together.
Sometimes the property of matter can change. This is called a chemical change.
Okay, very nice. So when the properties of matter change, it's a chemical change. Puppy, go ahead and read the rest for us.
When matter goes through a chemical change, it is not easy to change it back. It becomes a new kind of matter with different properties.
Very good. Nice work. Chemical. All right, we're still having a bit of trouble with this word, so let's break it down. We have the k. In this case, the CH is a k sound. Chem, chem, ical, chemical. One more time, everyone say chemical.
Chemical.
Very good. A chemical. Can you answer the question? What changes in a chemical change?
It becomes a new kind of matter with different properties.
Excellent. In a chemical change, the type of matter changes with different properties. In a physical change, the type of matter stays the same. Wood is still wood when you cut it. In a chemical change, the type of matter changes. If you burn it, it's not wood anymore, it's ash. It's changed, okay? First sentence. Bunny.
When you burn paper, you cannot change it back.
Very good. Bunny, what about when you cut paper? If you cut paper, can you change it back?
No.
Well, but is it still paper? Good. Yes, very good, Bunny. Nice work. And the second sentence, the rest of the paragraph, let's hear from Nam. Nam, can you please read the second sentence?
Seeing light and feeling heat are clues that a chemical change may be happen. All matter does not change in the same way.
Good. Can you say this word again, Nam? Say chemical.
Chemical.
And you forgot this part of it. Say this word one more time.
Happen.
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 There you go. Make sure you read carefully, okay? So, sometimes you see light and heat, like in a fire. Light and heat are clues that a chemical change is happening. Other than a fire, when else do you see heat or feel heat? Not in a fire. Is there another chemical change where you feel heat? Sam?
When we put our hand in the oven.
Yes, when you put your hand in the oven. Very good. That is electrical heat that we use to cook things. Everyone, please underline the answer to this question. What are clues that a chemical change is happening? What can you see or feel that tells you a chemical change might be happening? Go ahead.
Seeing light
and feeling hurt is proof that a chemical change may
be
be happening.
Very good. Seeing light and feeling heat. All right, very good. Seeing light and feeling heat. How is a chemical change different from a physical change?
Seeing light and feeling heat are clues that a chemical change may be happening.
Oh, we've already answered the question about clues. The new question is, how is a chemical change different from a physical change? Moon, what do you think, Moon?
I know.
Let's let Moon answer now. Go ahead, Moon.
But what did you say? I cannot hear anything.
This question right up here.
It's a physical change. So when you do something, it cannot return back. Like when you burn paper, it cannot be back like a paper before.
Very good. And what about a physical change? What if you cut the paper?
Cut the paper and it just be in half, but it's still a paper.
Excellent job, Moon. Great job. Great work. So, before, after. Guess the cause of the change. What made this happen? What do you think made this happen? Before, after? Oh, Moon again. Go ahead, Moon. Only one with her hand raised.
This one is before it not burn, and this after when it be burned.
Excellent job, Moon. Heat caused the matchstick to burn. The properties have changed. It is chemical change. And what about the second picture? What caused this to change, the before and after? Any ideas? Pasta, do you know why this has changed, the nail?
It has rusted.
It rusted. Do you know what causes rust to happen?
Water. I said water.
Oh, sorry, Pasta, I didn't hear you. You're right, water. Water and air can cause metal to rust. Rusting is a chemical change that happens slowly. This last one didn't change at all. Water and air do not change the properties of plastic. What could cause this plastic screw to go through a chemical change? Not water and air. What could cause it to go through a change? Blue Moon?
No.
Cherry, what do you think? What could you do to the plastic screw that would be a chemical change? How can you change plastic? Not sure, Cherry? Zook?
We can burn it.
Excellent, that's it. Simple and easy. Water and air do not change the properties of plastic, but fire and heat do. We could burn it. Heat causes the egg to go through a chemical change you can see and smell. How did the egg change? Blue Moon?
Change size.
Did it change size? That's a physical change. It is cooked.
It is good.
Solid now.
Solid now.
Not go back to being a raw egg. It is stuck like this forever now.
It cannot go back to being raw.
Okay. All right, guys. Today we learned matter can go through chemical changes, and chemical changes change the matter to a different type of matter. A cut apple can go through a chemical change. A cut apple can go through a chemical change. Here is your homework. Ready? Eyes on me. Cut 2 apples into pieces. So you'll need 2 apples. Put 1 cut apple into a bag or container and cover it in lime or lemon juice, then close it. So 1 apple you'll cut. You'll put it in a bag or container and add lemon or lime juice and then close the bag or container. Put the other cut apple into a bag or container and leave it open. So just cut it, no lemon or lime juice, and just leave it open.